Okay, so I have a question I got from somebody needed some explanation about absolute max, absolute min, max and min when there is a restriction given, when there's no restriction given. So I try to take this example. I have this example function f(x) equal to x minus 1, x plus 2 and x squared. I have the graph already made. If you see on the graph, there's one absolute min point, there's a local max point, there's a local min point. When there's no restriction given and question is to find the local max and absolute max, absolute min, so what you do normally, you will find the derivative, you put derivative equal to 0, and you find all the critical numbers and then all the critical points. Once you got those critical points, and then just checking the y value, you can determine if a given point, critical point or max or min point, is absolute max or absolute min, or just a local max and local min. All we need to do is to compare the y values of those critical numbers, and if there's a y value of one of the critical point and there's no other y value which is above it, then it will be absolute max point. And there's a critical number which gives you a y value which is absolute min. By comparing the y values, you can tell if it's absolute max or absolute min. This is done when there's no restriction given. So it's straightforward. You find all the critical points and then check what's max and absolute max or absolute min. If there's nothing, then there will be local max and local min. Remember, there's a confusion that absolute max and absolute min point is not found the same way we find critical points. No, it's not. It's the same thing. You found all the critical points and they may be all local max or local min, especially when we have odd degree function, polynomial function. We know there can't be any absolute max or absolute min point. So that means all those points will be the local max and local min. For even degree function, you know there could be an absolute max or absolute min point. So just checking all the critical points and checking their y values, you can determine if there's an absolute max or absolute min point. So the process is simple. You find all the critical points and check their y values. That's done when we have unrestricted domain. So going from negative infinity to positive infinity. Now I think the confusing question some people ask me, what if there is a restriction given, and if you want to find absolute max or absolute min or local max, local min for a restricted domain. So I took this example. If you look here, so if I do start from all the critical points between -1 and 0, and then we check if there's absolute max or absolute min between -1 and 0. So you will do the same thing. You find the critical number, but only check the critical number which are between a domain given -1 to 0. So in this case, if you look back on the graph from -1 to 0, and I don't see any other critical point in between. So that means I just have to check my endpoints, -1 and 0. From -1 and 0, there's no other critical point. Therefore, -1, -2 will be absolute min point, and 0, 0 will be absolute max point. Make sense? So this is in restricted domain from -1 to 2. What happens if I want to find all the absolute? So I took one more example at the bottom here, just to clarify when there's a restriction given. I want to find if there is any absolute max or min point between -1 and 1. So if you see on the graph, actually I did do calculation too. First thing you check the end points. What's f -1? What's f1? F -1 is -1, 2 and 1, 0. These are the end points. Between -2 and 0, if you go back here from the graph, between -2 and 0, there -2, sorry, I'm gonna check my domain from -1 to +1. Sorry, -1 to +1, I have, this is the end point, -1 and 0, but in between I have a 0, 0 and 0.693 and 0.397. My question is only to check if there's any absolute min or absolute max point between -1 to +1. So in between I have 0, 0, which will be considered absolute max point, and I have point 0.693 -0.397. This will be called the local min point. Sorry, 0, 0 is local max, and 0.693 -0.397 is the local min point. And you notice 1, 0 and 0, 0 are same height, and there's no other point between -1 to +1 which is above this. So both 0, 0 and 1, 0 can be considered absolute max point, and 0.693 and -0.397 will be local min point, and -1, -2 will be the absolute min point between -1 and 1. So if you look here, I try to put all those points here between -1 to +1. So we're not checking from negative infinity to positive infinity. And I see the points are -1, -2, 0, 0, 0.693, -0.397, and 1, 0. Because 1, 0 and 0, 0 are at same height, there's no other point which is above it between -1 to +1. Therefore, both 0, 0 and 1, 0 will be considered absolute max point, and 0.693 and -0.397 will be considered a local min point. And because -1, -2 is the minimum point, I mean the y value is the minimum from all those y values. Therefore, between -1 to +1, I should consider this one as the absolute min point, and 0, 0 and 1, 0 will be absolute max point. Even they are same height, so there could be two absolute max point, and there's only one local min point. So I'm going to go back to show you on the graph from -1 to +1. -1, -2 is the absolute min point. 0, 0 and 1, 0 will be absolute max point, and 0.693 and -0.397 will be the local min point. I hope I made it clear. So I think the only confusion was when there is a restriction given for x values. In that case, how we find max, absolute max or absolute min point. So try to watch this video once more and try to understand what I'm trying to explain.